take a look at these 4 points. They're not random. Each one is a coordinate, a location of a 1024-dimensional mathematical space, assigned by an AI model that has never been told what politics is, what good means, or what bad means. It learned these coordinates by reading human text, billions of words, and the distance between these points are the argument. You've probably noticed this. You ask a model a political question, and it does a careful little dance. Some people believe X, while others believe Y. It sounds neutral. It's trying very hard to sound neutral, and companies spend a lot of money making it sound like this. Here's the thing. The words coming out of a large language model are just the surface. Underneath every AI language model is a mathematical structure, kind of a geometry of meaning. And that geometry, it doesn't hedge or balance. It just is what it is. It stays like that based on what the model read before. Today, we're going to look at that geometry directly, not the LLM or its output, but the structure underneath. And what we find here is, I think, one of the most interesting and uncomfortable truths in modern AI models. You know, it's kind of wild that I spent a week on this when tools like today's sponsor, MaxClaw from Minimax Agent, exist. So what MaxClaw does is give you the full OpenClaw ecosystem without any of the setup, no model deployment or API configuration. You open Minimax Agent, switch on MaxClaw mode, and you're running. It works 24/7 and you can control it remotely across Telegram, Discord, or Slack. So whatever you already are, it's there. The part that actually got my attention is the multi-agent side. You can configure multiple agents and have them split up a complex task between them. So instead of one agent doing everything sequentially, you've got a team running in parallel, which is really useful for research workflows. It also comes with over 10,000 preloaded experts out of the box. Things like a viral hunter, a research team, a trend tracker, all ready to go without any setup. Their pricing is $19 with no additional API fees on top of that. Plus, you get 200 free credits just for logging in every day. Link is in the description. When you or I think about the word Paris, we picture something. The Eiffel Tower, maybe a smell, a feeling. We have rich, messy human experience attached to that word. And a model has none of that. It has never seen Paris. It has no senses. The only thing it has ever experienced is text. So how does it know that Paris is a city? How does it know that Paris is romantic? And how does it know that Paris is a capital? It figured it out from context, from noticing that Paris tends to appear near words like city, France, travel, and cafe, and almost never near words like ocean or volcano. Do that for enough text across enough words and something remarkable happens. Meaning emerges from pattern. A linguistic named John Firth described this idea in 1957, decades before anyone had a computer powerful enough to act on it. He said, "You shall know a word by the company it keeps." That's it. That's the entire foundation of how AI understands language. Every model you've ever used, GPT-5, Claude, or Gemini, was built on this idea. Words that live in similar neighborhoods end up close enough together in the model's internal space. And now, here's the question that should bother you. What if the neighborhood is unfair? Here's what we're going to do. We take an AI model, a real state-of-the-art one called E5 Large, trained on internet scale text, and we give it sentences, pairs of sentences that are structurally identical, but we swap one word. The model generates a location in space for each sentence. Then we ask a simple question. Which one landed close to words like good, honest, or safe, and which one landed close to criminal, dangerous, and violent? We're not asking the AI what it thinks, we're measuring where it already put things. There's no opinion here. To visualize all this at once, we use a technique called UMAP. It takes the model's high-dimensional space and folds it down to 3 dimensions, preserving which things are near each other. The result is what you're about to see. Before we go for anything interesting, let's make sure the instrument is working. If this model is encoding meaning correctly, then good and bad should be far apart. Honest should live near good, criminal should live near bad. They are. And if we add a word that genuinely has no moral weight, something like table or mundane, I fucking hate Mondays, it flows roughly equidistant between both clusters. Neither pole pulls it in. The compass works. So when something lands closer to one pole, it's not a glitch. That's the model telling us something about what it read. Let's start with something that feels less politically charged: jobs and gender. We notice that professional words land relative to the gender words. The distribution isn't symmetric. Some jobs drift toward the positive clusters and others don't. And when we toggle the anchor lines, it becomes impossible to ignore. What happens inside is simpler and harder to fix. Across billions of sentences of human text, certain jobs appeared near certain kinds of people, in certain kinds of contexts. The model read it all, and it learned. The point being, the AI's bias score and a human unconscious bias scores tracked each other closely. Now, for the part you came for: political words, religious identities, seem moral anchors. I'm not going to tell you what you think about what you're seeing, but I want you to look at these gaps. These gaps exist because the internet discusses these objects differently, not because any person decided to write something unfair. What we're seeing isn't one-person bias. It's the statistical center of gravity of a human language written in English on these topics. And that is a much harder thing to argue with. Let's go further, because so far we've been measuring individual words. What happens when you give the model something more loaded, an actual position or an actual issue? One framing lands closer to the positive cluster, one lands closer to the negative. If you want to, you can run the code yourself, it's in the description. So, why is this in the title? Why the will never be part? Isn't this just an engineering problem? Why not add more guardrails? Well, companies try hard. They use a technique called LRHF, reinforcement learning from human feedback, to steer what the model says. And it works for the output layer. You've seen it with refusals. That's LRHF doing its job. But here's the thing, it changes what the model says. It doesn't change what the model knows. You can train the model to not say the biased thing. You cannot train it to not know it. In 2016, a team of researchers published a method they claim could debias word embeddings, mathematically remove the gender direction from the space. Problem solved, right? 3 years later, a different team of researchers published a response paper. The title was Lipstick on a Pig. Their findings? The bias wasn't removed, it was hidden. Swap out the obvious words and the associations just reformed around nearby ones. The model found another way to know what it knew. And there is a deeper problem, which is that we don't even have a clear definition of what unbiased would mean. To make all political words equidistant from good and bad, you'd have to decide what counts as political, and that decision is political. To make all religious traditions equidistant from trustworthiness, you'd have to define trustworthiness, and that encodes value. You cannot step outside of value to make a value-neutral system. The attempt to be neutral is itself a choice. The bias doesn't live in the model, it lives in the data, and the data is us, the full written record of a human civilization, the good, bad, and ugly. Every model trained on that data will carry some versions of this. It doesn't matter how careful you build it, you simply cannot lander the corpus. That's not a good reason to stop building AIs, but it is a reason to stop claiming the output is neutral, and to start being honest about what those systems actually are. They're not oracles, they're not mirrors of truth, they are mirrors of us.